Okay, so 4D, the last one here in part 4. Again, we're doing a Taylor expansion, and for this time our function is arcsine of x, and we have a equals 1/2. So, like we've been doing before, let's plug them in and do the derivatives when we need to. The first number is just arcsine of 1/2. So remember, arcsine of 1/2 says sine of what angle is equal to 1/2, and that's pi over 6, using your unit circle things you should have memorized. So that's our first term. So our second term, we're going to need the derivative. So the derivative of arcsine is, again, something you should have memorized from Calc 1. So f prime of x, the derivative of arcsine is 1 over the square root of 1 minus x squared. So, again, we're going to be plugging in 1/2 to that. So, when we plug in 1/2, we're going to get 1 over square root of 1 minus 1/2 squared. And we have to multiply by x minus 1/2. 1 factorial is 1, so we don't need to divide by that. So finally, we need the third term, so we need the second derivative. So when we take the derivative of this, remember that you can equivalently write that as 1 minus x squared to the negative 1/2. If the top's a constant, basically what this boils down to is if the top's just a constant, there's no need to do quotient rule because you don't actually have a quotient. You just have one term with a negative power. So when we do the derivative of that, bring the power down, negative 1/2. 1 minus x squared, lower the power by 1, which would be negative 3/2. And then you have to multiply by the derivative of the inside, which is negative 2x. Well, negative 1/2 and negative 2 cancel out. And if we want to write this now as a fraction, we would have x divided by 1 minus x squared to the 3/2. Since that was a negative 3/2, that's on the bottom. Alright, so this is that's our second derivative. So for the third term in the expansion, we need to do the second derivative and plug in 1/2. So we would get 1/2 over 1 minus 1/2 squared all raised to the 3/2. You would have x minus 1/2 squared for the x minus a squared part, and 2 factorial is 2, so we have to divide by 2 as well. Alright, so here's all the terms, and now we'll go through and simplify them. Well, pi over 6 is pi over 6. Alright, so what do we do here? Well, 1/2 squared is 1/4. 1 minus 1/4 is 3/4. And we can change that then, instead of 1 over the square root of 3/4, that's just the square root of 4/3. And we have x minus 1/2. Alright, this one's going to be a little bit more complicated. So we have a 1/2 on top and a 2 on the bottom. Those would combine to be a 4 on the denominator. Because 1/2 is a 2 in the denominator. We have another 2 in the denominator. It becomes 4. Alright, here we have 1 minus 1/2 squared. Same thing we had over here. So 1/2 squared is 1/4. 1 minus 1/4 is 3/4. 1 over 3/4 to the 3/2 is, again, the same thing as 4/3 to the 3/2. We can just do the reciprocal there. And we have times x minus 1/2 squared over 4. So we need to just figure out a better way to write these things. And we can do that because these are all, 4 is a perfect square, so a lot of stuff's going to work out here. So we have pi over 6. Root 4 over 3 can just be 2 over root 3. Chances are if you get a problem where you have to do a derivative or a couple derivatives that are complex like this, the teacher isn't going to care that everything is rationalized as well. So I'm going to leave it unrationalized. If you feel like you need to do that, that shouldn't be too difficult though. Okay, here So what's going on with this one? We have this to the 3/2 power. So let's figure out what these are. 4 to the 3/2 power is the square root of 4, which is 2, and 2 cubed, which is 8. And we have 8 divided by 4, which would leave us with a 2 on top. 3 to the 3/2 power is not reducible, but recall that 3 to the 3/2 is the same thing as the square root of 3 cubed, which you can factor out the 9 part of that, though, to make that 3 radical 3. And, I mean, that's about as good as I'm going to leave it here. And we have our x minus 1/2 squared. So again, just using the Taylor expansion formula, getting the first few terms by doing this. Honestly, everything after doing the second derivative step is just a matter of algebra. But chances are, this is not going to be a multiple choice question anyway, so there's going to be plenty of time and space for partial credit and that type of stuff.